to 2020 virtual workshop. So we got quite a bit on store for today. So we'll start off with some climatology and GFB stuff, along with the frost freeze refresher. Then we'll have a quick fire weather refresher before we take a small break. And we'll return for some event reviews, WPC update, and training updates. So, and without further ado, I'll just jump right into first presentation, which is Tim's presentation. But since he's on midnight shifts, I'll go ahead and present it for him. So, all right. So this presentation will probably look familiar to a lot of you because it's kind of similar to what we show every year, but it's always good to get a refresher. So here's winter climatology for the Eastern Carolinas. Tim has a little note here saying, you know, a good PSA is to clean off your windshield because it's kind of hard to see from that little hole. But so what we're going to talk about is some of the averages and normals for the winter season in ILM, temperature, rainfall, and snowfall. Then we'll look at some winter climate patterns, a few historic winter storms for our area, which includes the typical storm track, and then an outlook for this winter. So jumping into the averages, this is a plot of normal and record temperatures for ILM. So obviously the 3 months for winter, the December to February period, is the coolest of the year. We average highs around 50s and lows in the 30s. You can also see that there's a wide variability in the winter months compared to the summer. And of course, since this is the coastal South, there's no time of year where we can't reach 80 degrees. Almost all the records in the winter are at or almost at 80 degrees. So that's fun. The all-time coldest readings for our area is 0 degrees in Wilmington, -2 in Florence, we got 7 degrees in Myrtle, and then Lumberton also reached -2. So looking at normal monthly precipitation, rainfall during the winter is usually evenly distributed, about 3 to 4 inches a month, with a 9 to 11 inch total for the winter. Differences in year-to-year rainfall are strongly linked to El Nino and La Nina, which we'll talk about more later. And you know, historically rainfalls range from 3 inches to 23 inches for the winter. So there's still quite a bit of variability in it. Now, to snowfall. The current official average annual snowfall for ILM is 1.6 inches. That's using the 1981 to 2010 average. It's also similar to our 150-year average using all our snow records. However, if we do not see any measurable snow during this month of December, the new 30-year average that we'll get next year that will drop to about an inch because we will lose 1989's record Christmas snowfall when we recompute the new averages in 2021. So my hopes for 2020 blizzard is slowly dwindling, but regardless of what the official average annual snowfall is, the large variability we see year to year makes, and the high standard deviations, it kind of makes the average annual snowfall basically useless when it comes to predicting the snow for a year. So it's just, we will be dropping in average snowfall. That's pretty almost guaranteed at this moment. Looking at measurable snow events in Wilmington, we've had 118 in the past 150 years, though granted about 60 of those have measured less than an inch. So snowstorm just means, yeah, any snow that's 0.01 or greater. January and February have seen 2/3 of all the snow that falls in Wilmington. The earliest accumulating snowfall was on November 20th, back in 1879, and the latest is March 31st. But we have seen traces as early as November 12th and as late as April 11th. So we've got a few month window. So 1 inch snows, 1 inch snows occur here about has occurred here 59 times over the past 150 years, with a recurrence interval of 2.5 years. 3-inch snows occur about every 5 years, and 6-inch snows have only happened 12 times in the past 150 years, and it has a 12-year recurrence interval. So those are definitely few and far between. Though I think it's been a lot more than 12 years since we've last seen 6 inches in Wilmington, but at least that's just the average. So move on to some climate patterns that most of you are very familiar with. So, you know, we all know ENSO. So Pacific waters are warm, it's an El Nino. When they're cool, they're La Nina. And of course, both of these influence both our summer and winter weather here in the Carolinas. So when we have a El Nino, specifically for the Carolinas, it usually brings us heavier winter rainfall because the subtropical jet is filled with moisture, comes up from the Pacific thunderstorms. And storm systems that are in a normal winter may bring us half an inch, while El Nino might bring that up to 1 to 2 inches because of the extra moisture. And local river flooding dramatically increases during El Nino winters. And so on the opposite end, where we have the La Nina, convection is suppressed in the Pacific due to the cooler ocean temperatures, and so La Nina brings us less winter rainfall because the subtropical jet is weaker and obviously drier. So yeah, those normal storm systems that would bring us half an inch now bring us less, as well as a decrease in the local river flooding during La Nina winters. So the current situation, I'm sure you've seen Tim's emails in the past. We are currently in a moderate La Nina that should last through the winter. So obviously this would lean more towards the warmer and drier winter outlook. The models also suggest that this La Nina may become strong during January. And if that does happen, it would be the first strong La Nina since the 2010 to 2011 winter. So see how that comes out, but it's definitely leaning more towards that, yeah, dry, warm months coming up. The next climate pattern that we like to talk about, AMO, the Atlantic multi-decadal oscillation, which is simply the average temperature anomaly across the entire North Atlantic Ocean. When it's warmer than normal, the AMO, we call the AMO positive. Cooler, the AMO is negative. So currently, we are in the middle of a positive AMO. I think have been for a little bit on average. Of course, it'll vary, you know, through the year, but overall, we are in a positive AMO. So what does that mean? Well, the AMO definitely has significant impacts on how severe winter cold outbreaks are, and most of those occur during the negative phases. So mid-60s to 80s, and then back in 1900s to 1920s. Now you see right now, since the mid-90s, we've been in a positive AMO, which leads to more heat and more hurricanes. So 7 of ILM's 11 coldest days all occurred during that negative NAO in the 1980s. I'm sorry, negative AMO in the 1980s. And so, yeah, the odds of a, you know, cold outbreak are a lot less during this positive AMO cycle. Here's the list of the coldest temperatures in Wilmington's history, and you can see, you know, 7 of them were from the 80s. 9 of them occurred during a cold AMO. Only 2 was during a positive. And so you see how cold this was 0. You can note that nothing has been added to this list in 31 years. The latest date on this list was 1989, which just so happened to be our coldest record. We did reach 10 degrees in 1994 and then 11 degrees during that January 2018 event, but both of them are off of this list. So it's been a while since we've had a real, cold outbreak. Okay, here we go. think this final one I'll mention is the NAO, the North Atlantic Oscillation. The two previous ones, ENSO and AMO, they change very slowly, months to decades at a time. The NAO is the opposite. It's kind of a wild card, and it can't really be predicted for more than 14 days in advance, and it could change week by week. So the thing with this is that it can easily overwhelm the other climate patterns. So a positive NAO occurs when there's a fast west to east jet that blows across the Atlantic between a strong Azores high and then Icelandic low. So the cold air remains bottled up near the North Pole, and it can't dip south. So we stay pretty warm. On the opposite end, the negative NAO occurs when the Azores high and Icelandic low both weaken, and the jet stream weakens and develops a loopy meridional flow across eastern North America and Europe. So, the polar vortex weakens and sometimes splits, which, allows bitter cold air to possibly move into our area. Again, we can't predict this for, that far out, so have to keep an eye on that as well. Look at some of our greatest snowstorms for our area. This was the Great Southeastern Snowstorm of 1973. It's the largest snowstorm in history for much of South Carolina. Florence got 17 inches and Darlington 18. In the animated loop, you can notice the track of the low crossed central Florida before it moved northeastward across the Atlantic Ocean. And this is kind of that classic track for southeastern snowstorms, moving southeast and over that, benchmark that we love that I'll mention short in a little bit. But Wilmington got 12.5 inches, and yeah, it's one of our biggest snowstorms. I think it's the second on record for Wilmington, or third? No, second. The greatest snowfall in Wilmington, of course, was the Christmas snowstorm 1989. We got 15.3 inches here, and also had our coldest temperature of 0 degrees. So we had a very cold Arctic air mass in place. The storm didn't cross Florida, but it did develop off the southeast coast and then move northeastward. So we stayed on that cool side of the low. The third largest snowstorm in Wilmington history, which isn't included here, was the 1896 snowstorm, where we got around 11 inches. That also was kind of the classic low off the coast. So let's explore the ingredients for snow across our area just a little bit. In this scenario, a Canadian cold front pushed through the southeast states, kind of sits across central Florida and Gulf of Mexico. So we have dry, cold Arctic air across our area. And then we see a low pressure develops along the front, and then it begins to spread rain along the Gulf Coast. So this is snow minus 24 hours. So what happens then is the low, reaches the Florida west coast. If the Arctic air is still across our area, the rain starts spreading north and then changes to snow with only a tiny mixed precip transition zone. And snow falls for about 12 to 24 hours before it tapers off as the low crosses that benchmark, which is around 30 degrees north and 75 degrees west. The Arctic air continues, as the winds turn northwesterly behind the low. So this is the classic Miller A storm track, single low that moves off the Gulf and Atlantic coast. If the low moves too far north, it brings us warm air that changes the snow to rain. If the Canadian high feeding the cold and dry air southward moves east too quickly, our surface winds will veer northeasterly and bring in warm air and rain. If the low moves too far south, moisture remains too far south, and we have cold air but no precipitation. So there really is that, pretty narrow window where we need that low to move to get the ideal snowstorm for our area. Probably why it doesn't happen so often. And then, of course, you have that Miller B storm track where a low moves across the southeast states, but it weakens as it enters the Appalachians. And then a new low develops off the Atlantic coast. So this pattern can bring us substantial snow. This pattern could bring substantial snow to the mid-Atlantic and northeast, but it typically only brings cold rain to the Carolinas. If the air is cold enough for freezing rain, we could get an ice storm in our area, but we actually do get more snow than freezing rain here, which, I mean, we don't really get much snow, so we get freezing rain even less often. And there's a lot wider transition zone between the rain to ice to snow across the Carolinas. So, I'm sure you've both seen Tim's outlook for the upcoming winter season. It was on our webpage, and he sent us an email. So this is just a kind of the highlights. So due to that, moderate, possibly strong La Nina, it'll starve the subtropical jet stream of moisture, create more dry, sunny days. We also, in that warm AMO, that correlates less potential for cold Arctic outbreaks. So the long-term and our long-term winter temperature trends, climate-wise, are kind of flat in our area during the winter, even if the rest of the world is seeing warmer winter temperatures. We do have warming trends in our other 3 seasons, just not really winter. So all of these combined, we do kind of have an increased potential for above normal temperatures and below normal precip through February. Looking at some of the climate models, this is the climate forecast system, and it's forecasting about plus 1.8 to plus 3.6 degrees Fahrenheit above normal for our winter. European seasonal forecast also showing a 70 to 100% chance that we will have a winter in the upper third warmest of all winters. And then the Canadian model is also predicting 1.5 to 2 degrees above normal, maybe up to 2.5 degrees above normal next 3 months. So all indications are that we will have a warm winter, which unfortunately means less chance for snow, but I like my wish casting. So that's it for the presentation. We have any questions? All right, well, if anyone thinks of a question, you can, definitely ask me or ask Tim. Like I said, a lot of this was review, but it's always good to touch base with it every winter.
Hey, Vicky.
Yeah.
Do we have any idea of what the I know freezing rain is really, really rare, but do we have, and I'm sorry if I missed this in your discussion, but do we have any insight on return periods of events or any, even if it's qualitative nature of the occurrence of freezing rain events?
I see. I'm gonna look it up right now. I don't know how many of you have checked it out, but like Tim has an awesome snowfall and ice storm Climo pages online, and so I have them linked on our winter page. But yeah, Wilmington ice storm since 1947.
Okay.
And so yeah, the latest one is 0.1 inches in 2018. And looks like every few years we might have, yeah, like 0.01 to 0.1. So they do come, I mean, probably as frequently as we get snow. So it could be anywhere from, we had a 0.4 and a 0.5 ice storm in 2015, 2014. So I think those are actually our biggest ice storms since 1947.
That's from Wilmington.
Yeah, this is for Wilmington.
Because we had I don't know if Steve's the one or not, but we had a big one that went through like Columbus County down towards Williamsburg. Oh, that was over 15 years ago, I believe. So we do have some big ones.
I think it was 2005. We did a paper on that one, and 2014, our PD counties got absolutely obliterated. I think 1.5 inches of accretion, if I remember correctly. I'm going to talk about it later on, but I know some of those big ice events in those interior counties, people that I've talked to said they're more damaged than some of the hurricanes they've had.
Yeah. Yeah, if anyone's interested, it's weather.gov/ILM/ILM ice database. that lists like Wilmington ice storms, but he also talks about 1973 and then the 2014 ones here as well. That also mentions the 1 to 1.5 in PD region. And so
the reason I brought it up is we had one in Pitt County. I can't remember 2007 or 8 or something like that. And I think it hurt us because climatologically it's extremely rare up in that part of North Carolina, and typically you get different P types, and I think that definitely hurt us a little bit from a messaging and warning standpoint. But in any case, yeah, I appreciate the talk, and thanks for sitting in for Tim. It was really good information.
no problem. And it looks like Tim actually has the average return on this webpage as well. So all
Awesome.
events, including trace, comes back every 1.5 years.
There you go. Thanks.
So